Okay, we're ready, are we? Are we? Everybody ready?
Sure.
Okay, here it is, a linear system. This is where we start. Okay, a linear system is a collection of linear equations. It's a collection meaning one, two or more equations. Okay, how many do we have? Two equations. Okay, so a linear system is a collection of linear equations involving the same set of variables. This one has x and y. This one has x and y. Same set of variables. The system below has two linear equations in two variables. Okay, this is all a system is. Two equations with what? Two variables. I usually do that. I put little braces around it just so you know. Okay, so this is what a system looks like. If you want the solution, a solution to this system will be written as an ordered pair x, comma, y. To be the solution, it must satisfy what? Both. It says both equations. So guys, if I ask you, is 4 negative 3 a solution, you're supposed to say yes or no. Well, the only way you're going to say yes is say, this needs to work in both solutions. So you must plug it into this one, and then after you're done, plug it into this one. And it's got to work in both. Otherwise, it's not the solution. Okay? So if I did that, you do it right now, by the way. If we do that, we're going to plug 4 in from what? X. So 5 times 4 plus 7 times what? Negative 3. And we're hoping to get this number 1. Well, this is 20. Take away 21. What are you getting? Negative 1. What did we want? We wanted positive 1. Is this working?
No.
What, negative 1 equals 1? No, it doesn't. So this point, this ordered pair, doesn't even work in the first equation. It's supposed to work in what? Both. So since it doesn't work in the first one, should I waste my time and do the second one? No, unless you just don't care. You want to try another one. I wouldn't. I would say right away, not a solution. So is it a solution? The answer would be no. It's not a solution. Okay? Well, I want to show you that there are solutions out there. So let's hope this one works. Is 3 negative 2 a solution? Yes or no? Well, try it. Plug it in. Plug it in both. 3 would go into 5x. Sorry, 3 would go into x. 5 times 3 plus 7 times what? Negative 2. You'd end up with 15. Take away 14. You'd end up with 1. What do you think?
4x.
Is that what you want? That's what you want. 1. Okay? Okay, so is that the answer? Is 3 negative 2 the answer? Or yep?
Yeah, not yet.
Not yet, because you got to do what?
Put it in the other one.
Put it in the other one. Okay, so let's put it in the other one. 3 goes in for x. It's 4x, it looks like. Okay, and minus y. Which one's y? Negative 2. Okay, that would be 12. What? Plus 2, which would be 14. What did you guys want? Did you want 14? Yeah, check, check. It works twice. It works in both equations. So is it a solution?
Yes.
Yes. The idea behind a system is you have to find an ordered pair that works in both equations, or else it's not a solution. Okay, so that's the idea behind it. Now there's 3 ways to actually do this, and here they are. It's the graphing method, which is today. Substitution, tomorrow. Elimination, Wednesday. Now how are we going to graph and get the solution? How's this going to work? How do you graph a system and get the answer out of it? Okay, solve for y. You're telling me how to do it, okay. What I was trying to get you to say was, how are we going to see the answers if we graph? Yeah, there's going to be a line going this way and a line going this way, and guess what they're going to eventually do?
Cross.
They share a point. Wherever they cross, the intersection, that is the solution. So this is your job today. Find the intersection. That's what your job is. Okay, so let's go down further. Okay, right here it says one way to solve a system of equations is by graphing both equations. When you are done graphing, look for the intersection point that both lines share. Intersection point that both lines share is known as the common solution. Okay, so that's what your job is today. All right? Here are three situations you might run into. One of them is called intersecting lines, coinciding lines, and parallel lines. They all have different solutions. Intersecting lines get how many solutions? One solution, that's it. Coinciding lines, that would be geometry last year. If two lines coincide, one line lies on top of the other line, so where do they touch?
Everywhere.
Everywhere. So how many answers are there? Infinitely many solutions, right? So here's an answer, 2 comma 7, 4 comma 1. Here's an answer. There are so many that you can't say them. You just say infinitely many solutions. And then the final kind of system is called parallel lines, and that would be they don't touch. And if they don't touch, there is no answer. Okay? Now here's the pain. The biggest pain with this picture is they make you memorize these words. Now, the word consistent to me, consistent means you get answers. That's all it means to me. So when they start talking, is it consistent? Consistent means you get answers. Now, if all you get is one solution, it's called independent. And that should make sense. Independent all by itself. Okay, one solution. If you get millions and billions of answers like this one, then you just say the opposite. It's dependent. So independent, one answer. Dependent, billions and trillions of answers. Infinitely many solutions. Now, if you get nothing, you don't get any answers, then they just call it inconsistent. Okay? So they do make you memorize those words, but for the most part, what I want to know is, what is the solution? Is it this, infinitely many, or is it none? So that's what I'm very interested in. Okay, can you answer those four questions? Answer the following 4 questions about linear systems. True or false? Just answer them. Give you about 30 seconds. Inconsistent linear system. Inconsistent, that's this one right here. Okay? Intersect at 2 points. False. An independent linear system, that would be this one right here. Has one solution.
Yeah.
True. A dependent linear system, that'd be this one right here. Okay? Has no solutions. False. It's got billions and billions of solutions. Okay, this one's kind of weird. 2 unique lines. 2 unique lines. What's that mean? It's 2 lines. They're unique.
They're different.
They're not the same, right? They're whatever. They're just different lines. Okay, which have the same slope, form an inconsistent system. If they have the same slope, that means these 2 different lines have the same slope. They look like this. Okay? And what do you think? If they're unique lines, they're different.
True.
Yeah, this is true. Okay? Right there. Can I move on? Because here's where you start working, guys, right here. You need to take this system and you need to solve it, find a solution by using the graphing method. All I'm asking you to do is graph each line and tell me where they intersect. Now, what are we going to do? Solve for y. Just solve for y and graph it. I'll be quiet for just a little bit. Give you another 30-second head start. Okay, I solved my top equation, that's what I got. And about what you got? If I make a mistake, let me know, please. Alright, bottom equation. Okay, that's what I got in the bottom equation. Y equals negative 1/2 x minus 4. Yes?
Yep. Yeah.
Okay. Anybody got an answer right now? Anybody? Okay, 1, 2, 3. 3 people have an answer. Okay. All you gotta do is graph it, and if you graph it, they should collide somewhere. Alright. This one crosses at 4. 1, 2, 3, 4. Slope is up 3, right 2. There it goes, and this one would be, I guess on the other side it'd be down 3, left 2, down 3, left 2. Okay, something like that. Okay. This one crosses where? -4. So I'll go 1, 2, 3, 4 right there. And from there I'll go, tell me, down 1, right 2, down 1, right 2. Okay, so down 1, right 2, down 1, right 2. Okay, there's the line, but I don't seem to be getting any closer to the blue line, so what do? Reverse your direction, so what? Okay, up 1, left 2, up 1, left 2. Oh, I got it. There it is. Up 1, left 2. Shoot it through. There it is. That should be the solution. Haley, what is it? Okay, she says -4, -2. You guys agree or disagree?
Agree.
Agree? Check your solution. Guys, on a test, you give me these answers, you can check all these answers. Just plug them in and see if they work. If they work, you can probably say, Mr. Payne, I don't have to correct this. I already did it for you. Okay, so we put that in. -4 goes in, I lost my equation. Help me. What's the top equation say?
-3x
Okay, -3 times x
plus
2y.
plus 2y equals 8.
Yeah.
Okay, let's see if this works. Ready? This and this is positive 12. Take away 4, 8. Check, it works. What's the other equation?
X plus 2y.
X plus 2y?
Yep.
So -4 plus 2y. What should it equal?
-8.
-8. Okay, this is -4. And it followed by another -4, which is -8. I like it. I got it. I trust that answer. Good? Hey, why do I have to, why should I check it? I mean, I can tell. You guys, I know that's -4, -2. I know that's right. Why do I have to check? Yes, maybe I solved for y incorrectly. I graphed the line correctly, and I did everything right, and I got an intersection point. The problem was I solved for y wrong. So that's why you want to check these answers, okay? So if you think you're that good, then you don't have to check. But really, guys, comes to the test, I would check. Okay, is this where we're at? Just making sure we're in the right spot, right? Okay, okay, same thing, just story problem. All right? First things first in a story problem, represent your what? Variables. You need to start by saying this right away. X equals something and y equals something. What am I looking for in the story? Okay? And what you're looking for is usually the question. All right? Somewhere up there there's a question. Your school sells tickets for its winter concert. Student tickets are $4. Adult tickets are $8. If your school sells 200 tickets and makes $1,000, how many of each ticket did they sell? What's X?
Tickets?
Just tickets?
Maybe,
Student.
How many of each ticket did they sell? There must be
200.
There must be something different about these tickets.
oh, adults are 800, I didn't see that.
There's adult tickets and there's student tickets. You gotta tell me which one's which. What are you gonna let X be?
Student.
Students, okay. So number of what? Student tickets. Okay, but not just student tickets. There it is, it's right there. Sold. They said, how many of each ticket did they sell? So you might want to put sold. So how many student tickets did I sell? I bet you Y has to be what?
Adult.
Number of adult tickets sold. Bingo, that's it. So when you start these story problems, let X be something you're looking for, let Y be the other thing you're looking for, and then write your system down here. Now, I'll give you a big hint. Okay, here's what you do when you write these systems. A big hint for you guys is simply go up in your story and find your totals. There's some number up there that stood for a total. So 200 what?
Tickets and then
1,000.
1,000.
Oh, I'm way off. Ah, I got it. This is bugging me. The top part of my screen is way off. Okay, you're right. It's 200 tickets and what else? $1,000. $1,000. Okay. Now, I want to show you something before you go on. I want you to understand this. That's 200 for a total, and that's 1,000 for a total. You got to understand something about your two totals. What they stand for is 200 what? Tickets. So you must know this is tickets, and you must know that's what? That's money. That stands for money. So the two totals are different. One's money and one's tickets. So when you write your system, what you do is you put your two totals down like this. Okay, what is going to add up to 200?
X
The
was
number
Y.
of tickets.
Yeah, I was hoping you'd say tickets plus more tickets have to add up to total tickets. Well, how many student tickets did you sell? You don't know, but you could call it X. I sold X student tickets plus I sold what? Y adult tickets. So to me this says tickets plus more tickets equal total tickets. Agree? Guess what's happening down here? This stands for what? Money. It's got to be money plus money equals money. Well, how much money did the student tickets bring in? $4. Well, this is just a number like 40 tickets. 40 times 4 is how much money I brought in. So 4x plus 8y. There you go. Now some of you probably already knew that, but I just wanted to say it's ticket plus ticket equal total tickets, and money plus more money equals total money. If you put the 4 here and the 8 here with the 200, is it going to work?
No.
Nope, it won't work. You're going to get an answer, but it's going to be wrong. Okay? All right. Now we get to graph. Okay, but before I graph, you know what? Will you just tell me what the x-axis stands for? Number of student tickets sold. So yeah, just student tickets. So Y would be what? Adult tickets. Okay. Okay, there you go. Adult tickets, right? Okay. I can't graph until I get some points. No. Or solve for Y. But I'm going to tell you this. If you guys solve for Y and you do slope and Y-intercept, this is messy because the numbers are really, really what? Big. I wouldn't do it that way. I'd go back with the other method. The other method is XY intercepts. Let's pretend I sold 0 student tickets. Put 0 into this one. Ready? Cover up the X. What does it say? Y equals 200. Is that truly a point on my line? 0 plus 200 equals 200? Yeah. Okay, give me another point. Why don't you let adult tickets be 0? Cover up the y. What's it say? X equals 200. Hey guys, look. 0, 200, 200, 0. These are points on your line. I can graph these, connect them, and I'm done. Okay, but let's go get this one. Out of this equation, what if I say 0 students came? Cover up the x term. 8y equals 1,000.
120.
Okay, divide by 8. 125. 125 adults came. What if I said no adults come? How many students can come? Cover up the y term. 250. There, you got 2 good points off the second line now. Right? Okay, here's the deal. For you to graph these ordered pairs, look how big the numbers are. The biggest x value, 200, 250. Which one's the biggest? 250. Somehow you got to make it out to 250 out here. What should you go by?
50s.
50s.
Or 25.
Okay, so you go 50s, 50, 100, 152. 250 is right there. That's too quick. You don't want your 2 lines in this corner. You want it spread out. You want 250 to end up back here. 25s?
Yeah.
Well, here's the problem with 25. That's 100. That's 200. 225. That's 250. You know, you're right there. I'd like 250 to be as far back as possible. Okay. You know what you can do though? Here's what you can do. How many squares do you have? How many squares? Have you guys counted these at all?
20.
20? Did I hear 20?
Yep.
You know what you could do is take the number 250 and do what? Divide by 20. Cut out the zeros. You're actually going to go by what?
12 and a half.
12 and a half. Now here's the deal. 12 and a half is a terrible number, but you know what? It isn't bad. It isn't bad because if you did this, 12 and a half, what's the next number?
25.
25. Every 2 squares is what? 25. I'd go by 25, and I'd say 50, 75, 100. I'm stretching this baby out as far as I can go. I'd do that, guys. That's what I would do. Get this thing way out here. 150. $200 and 250, like it. That's what I want. Get that 250 as far out there as you can go. How about the 200 going this way? The biggest y value is right here, 200. Yeah. You know what? I think I'll keep it the same. I don't want this to go any different. Let's just go every 4 squares is 50. Okay, 50. 2, 3, 4. That'd be 100. 150. 200. Okay. Plot these 2 points. Plot those 2 points. Connect the line. Draw as straight of a line as you can. Oh, I forgot. If you guys have a ruler, great. But if not, try to share if you can. I got one of those.
We get one more.
Just share.
Oh, okay.
They're falling everywhere.
So, question, why can't you just put that into y
Who said one more?
Oh, we're good.
You good?
and then other things?
Okay.
That's what I did at first. Yeah, that's what I did.
Okay, I have one more if anybody wants one.
Sure.
Okay.
Oh,
All right, so 0, 200 is here. 200, 0 is here. And if I connect, I get that. All right, the other one is 0, 125, which would be here. And 250, 0, which would be here. And if I connect those two, whoa, way off, sorry. That's why you want a ruler, because of what I just did. It looks to be somewhere right here. So if I went down, 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 yuck, I'm not hitting 150. I'm hitting 140 something, and looks like about 60. And I know that's not right. Last hour I did this perfect. What are you guys getting?
Yeah.
If you drew straight lines, this works really nice.
Yeah, that's right.
One what?
150 to 50.
150, 50? Okay, what does that stand for? X stands for student tickets, adult tickets. Now, if it's right, it should work where? Should it work in both? Let's do it. 150, X plus Y. It's supposed to equal 200. It did. The other one was 4 times X plus 8 times Y. It's supposed to equal $1,000. Yep, that's good. That's good. And together that makes $1,000. It does work, doesn't it? Now come back up here. Don't do this. Don't turn your page yet because you haven't finished. You can't just say 150-50. Guess what you have to say?
150 students.
Student tickets and adult tickets. When it's a story problem, you gotta throw on the units. What are they? What do they stand for? Okay. Good? Did you guys get 150-50 or you just copied my work?
No, I got it.
Because I didn't get it. I was off. Look, I was off by a lot. But if you drew nice straight lines with those rulers, you're probably good. Okay. All right, next. Oh, this is just a big review of what you and I did 2 pages ago. Intersecting lines could happen, coinciding lines could happen, parallel lines could happen. If this happens, you're going to get one solution. If this happens, coinciding lines, you'll get infinitely many solutions. If this happens, you'll get no solutions. Then they threw all these words down here. One solution, independent. Infinitely many, dependent. No solution, inconsistent. But by the way, the word consistent means what? What did I say it meant? Consistent to me just means you're going to get answers. You're going to get answers. Here, independent 1, dependent millions. Okay? Now, notice, here's what I want you to notice. Look at these and notice the slope and the y-intercept. Except for number 1. Throw this one out. We don't even need it. All I want you to tell me is this. When you have an intersecting system going on, like this, what can you tell me about the slope of those 2 lines? Period 4 couldn't do this. One's positive, one's negative. In this picture, yes, but it doesn't have to be that way, because look, that's it. That's the intersecting one spot. They're both positive slope. They're both negative slope. So they can be both positive, they can be both negative.
They just can't be the same.
Okay, they can't be the same. Another word for that is, they are what?
Different.
They are different. If you have 2 equations with different slopes, you automatically know you have what system? You have intersecting lines right now. Guys, different slopes, intersecting system. What about dependent systems like this? What do you notice about the slope on this one? They're what? They're the same. What do you notice about the y-intercept? Right here. Same. So if you have same slope, same y-intercept, you have coinciding lines that have infinitely many solutions. We know this as dependent consistent. Okay. Next, parallel lines. don't touch, no solutions. How are you gonna know this happens? When the slope is what? Same slope. What else?
Different line.
Y-intercepts are different. Look, different. So if that's the case, you guys can look at systems and you can say, well, that system, that's just intersecting lines. That one's parallel, they don't touch. Take a look down below. Without graphing any of these systems, don't graph. Is it going to be independent? Oh, by the way, independent is this. Two lines that intersect at one point. Is it going to be dependent? That'd be this. Or is it going to be what? Inconsistent. That'd be this. Okay, which one is it? Well, how are you going to solve that system? Tell me what it is without graphing. What would you do?
Solve for y.
Solve for y. Because if you solve for y, you can compare the slopes, right? That's all you have to do. So let's do this quick. Ready? This one's not too bad. This one's just going to be y equals, move the 3x over, it becomes what? 3x plus 4. If you're not good at solving for y, you will get really good this chapter, okay? This one, a little more difficult to solve for y. Negative 1/3 y, right? Equals, how does x move over? 1 minus x, right? How do we get rid of a multiplier like negative 1/3? What are you going to do?
Divide by
You can do that. That gets messy. That's messy, but you can. Easier one would be multiply both sides by what number?
Right there.
Okay.
Yeah, 30.
3 is good, but you want the negative to go away. Let's go negative 3. Because what's a negative times a negative? And 3 cancels with 3. We're down. Well, now we got y. Y equals what? Multiply by negative 3. And negative 3. What are you getting?
3x.
Oh, I see. You're over here. 3x. And then what? Negative 3. Okay, guys, compare your two equations. You have what for slopes? Same slope. So it's either going to be parallel, don't touch, or it's parallel and touch everywhere.
Parallel.
Negative 3, positive 4, they're separated. It's this. So which one is it?
Inconsistent.
It's inconsistent, yep. All right, this is an inconsistent system. Which more or less just means what? Something like this. That's all it means, right? Just parallel lines, they don't touch. All right, do the middle one. Try solve for y. The bottom equation's pretty quick. Bottom equation, all I had to do was subtract 4x. Top equation. Move that over. So 3y equals, right? Divide by what? 3. Y equals, divide by 3, out. 3. What are you getting? 2/3 x minus 1. Guys, compare the slopes. Negative 2/3 compared to negative 4.
different.
Different slopes. What kind of system is this? Independent. Okay, it's independent. Okay, which basically means you have two lines that cross. You get one answer. Okay. Would you mind if I didn't do the next one?
Yeah.
And just, what is the system? It's the other line, isn't it? Isn't it going to be dependent? So if I go back up really quick, I'll just say, well, this one has a slope of 2. And then this one, if you solved it for y, I get that. Then I would get 2x minus 3. You see it, guys? Slope is 2. Slope is 2, right? Y-intercept is -3. -3. Same slope, same y-intercept, same line. That's why we go with dependent. That'd be this line, followed by the same line right on top of it. Good? Okay, I don't know what you need. I don't think you're gonna need more than 2 sheets of this, because you got 6, you got 12 grids here.
What's the project we got to?
The project, ignore that for now. I'm gonna look harder at that. I don't know what I'm gonna do. I think one's good enough, to be honest, okay? If you ever get a story problem, do this. Story problems. Make this the y-axis. You watching? You looking? All story problems. This is the y-axis, this is the x. Because really, all we care about is what kind of numbers. Positive in story problems. You're not gonna sell -55 student tickets. You're not gonna do that. So start down here with the origin on a story problem. Okay? You want that? Well, feel free. Take 1, take 2 if you want. Okay? Rulers, you can use them until the bell rings, but after the bell, then put them back in my bin, please. Yes.
Wednesday was the day that left those that are